Once we've established our trial aggregate blends, our next step is select the trial asphalt content expressed as a percentage of the total mixture mass. We'll walk through the process to select the trial asphalt content for aggregate blend 1. The information that we need corresponding to aggregate blend 1 is given on this slide. Our mixture nominal maximum aggregate size is 9.5 millimeters. Our bulk specific gravity of our aggregate blend is 2.558. Our estimated effective specific gravity is 2.616, and our binder specific gravity is 1.03. The first step in selecting our trial asphalt content is to estimate the volume of asphalt binder that will be absorbed by our aggregate particles. Recall that aggregate particles contain pores which can absorb asphalt. The absorbed asphalt will be unavailable to bond aggregates together and is therefore an important design consideration. We estimate the volume of absorbed binder using equation 5 and assuming typical mixture design information, where we have 5% binder by mass, 95% aggregate by mass, and 4% volume of air. Our ultimate superpave mixture design goal is to achieve 4% air voids after compaction. We will estimate the volume of absorbed binder for trial blend 1. For trial blend 1, again, we will assume that we have 95% aggregate by mass, or PS, and we will assume that we have 4% air voids. We divide the quantity of PS times 1 minus VA over the ratio of our binder mass proportion, or 5% in our case, divided by our binder specific gravity, 1.03, plus the ratio of our aggregate fraction, which is 95% by mass, divided by our aggregate effective specific gravity, which we estimated to be 2.616. And then we multiply this quantity by 1 over our bulk specific gravity, which we calculated to be 2.558 in the previous video, minus 1 over our effective specific gravity, which again was estimated to be 2.616. This leads to a calculated estimation of binder volume absorbed of 0.0195 centimeters cubed over centimeters cubed of asphalt mixture. Next, we will estimate our required effective asphalt binder volume. Our effective binder volume represents all of the asphalt binder minus that which is absorbed by our aggregate particles. Our required effective binder volume to glue our aggregate particles together is a function of our aggregate size. Smaller aggregate particles will have a higher surface area per unit volume than larger particles. Therefore, we estimate our required effective binder volume as a function of our nominal maximum aggregate size, Sn, using equation 6. We will estimate our effective binder volume for trial blend 1. Recall for trial blend 1 that our nominal maximum aggregate size is 9.5 millimeters. This leads to an estimated required effective binder volume of 0.11 centimeters cubed per centimeters cubed of asphalt mixture. Now we are ready to estimate our trial asphalt content, PI, using equation 7. Before we can apply equation 7, we have to calculate WS, which is our mass of aggregate in grams. We'll do this for trial blend 1. For trial blend 1, we're again going to assume that PS, our mass fraction of aggregate, is 95%. And we'll assume that our air void content is 4%. We divide this by the ratio of our PB, which recall was 0.05, over our binder specific gravity, 1.03, plus our PS, again 0.95, divided by our estimated effective specific gravity, which is 2.616. This gives us a WS value of 2.215. Now that we've calculated our aggregate mass, WS, we can use equation 7 to calculate our trial asphalt content. Our GB is 1.03. We multiply that by our total binder volume, which is the sum of our effective, 0.11, and our absorbed, 0.0195. We divide this by the same quantity as in our numerator, 1.03 times 0.11 plus 0.0195. That represents our mass of binder, and we add that to our calculated mass of aggregate, WS, which was 2.215. We multiply by 100 to convert our units to percent, which gives us a binder content of 5.668% by mass of mixture, which we will round to 5.7%.